Section 2.1 is about relations and functions. Any set of ordered pairs, that's what this is. Any set of ordered pairs. So you give me any list of coordinates, and that's called a relation. Any set of ordered pairs. Okay, obviously our coordinates come in the form of usually x and y. But you give me any group of ordered pairs. So in example 1, they say, and you really need to be able to graph. So one of the necessary things that's in this particular chapter is graphing. Seems like a pretty simple subject. But right there's a set of ordered pairs. We would call that a relation. Any set of ordered pairs, that's a relation. Now, we are interested in a specific type of relation called a function, but we'll get to that definition in a little bit. Okay, so just as a reminder on graphing, shouldn't be too terribly, -2, 4, obviously 2 to the left and 4 up. That would be my first coordinate. 3, -2 would be 3 to the right and 2 down. -1, 0, that's left 1 and up and down nothing. And 1, 5 would be 1 to the right and up 5. So here's the set of ordered pairs in graphed form. Okay, this is the relation that they've asked me, and they asked me to graph them. Okay, pretty simple stuff. The domain, all possible x values. All possible x values. So in this particular example, what's the domain? Well, I've got a -2, I've got a -1, I've got a +1, and a +3. Those are the only possible x values. Now remember, domain is only about x's. It's not about y's. Now, you notice that I didn't write some kind of interval from -2 to 3. A lot of times I'll get kids that write, the wrong thing. They write -2 minus 3. Okay? Because they think that that's what they should write, -2 to +3. And they think if they put a dash in the middle, a hyphen, that somehow that means the same thing in the world of math that it does in the world of English or some other subject, I guess. That is not acceptable for a couple different reasons. One, it's really terrible looking notation. Secondly, there are a lot of numbers between -2 and +3. An infinite number, like -1.375. But that's not one of the possible x's for this group of points. So we do not mean an interval in this case. Okay, the domain of this is not an interval. Now, are there situations where it is an interval? Yes. But not in this case. There's only 4 coordinates on this particular relation. Now, range, the range of a function would be all possible y values. So, when I look at this particular situation, I have let's see here, -2, 0, 4, and 5. -2, 0, 4, and 5. Truthfully, you do not need them in order, but a lot of times you do see them in order. It does not mean that you have to have them in order for the range. You're just looking for all the possible y values. So all the x's here, all the y's here. Now eventually we're going to get to things that have, an infinite number of points, and then we're definitely going to need to write intervals. Okay, but for now, in this particular situation, You're listing out x values and you're listing out y values. Question: if an x value appears more than once, do I need to write it more than once? The answer is no, it does not need to be written more than once. Okay, you are only writing out the possibilities, not how many times they occur. And I'm pretty sure there are people ignoring my notes right now, and when we get to quiz and test questions, they're going to just write it as many times as they feel like writing it. Not sure quite why. You might get laughed at parties, and that would not be good. So you might want to rethink that whole thought, because I would not want people to make fun of you. Now, if you look in the book and you see something called a mapping diagram, do not worry about that. We're not going to be doing mapping diagrams, okay? It's kind of a visual, but I'm not really that keen on it. Now, I do want you to understand that the real type of relation that we're interested in is called a function. Now, a simple definition says each x value has exactly one y value. Each x value has exactly one. Why is that so blurry? Oh, there it is. Each x value has exactly one y value. Alright, so what does that really mean? It means that we could pass a vertical line through a graph, and since we have a pen in our hand and it can be made to look like a vertical line, a lot of times we use a pen or pencil, something like that. It's not called the pencil test, like you might have seen in middle school. Okay, the vertical line test, also abbreviated VLT. If something, if 2 points fall on same vertical line, then the points fail the vertical line test. So when we're trying to determine if something is or is not a function, we're going to use this vertical line test. So for instance, in the book, they show you this picture of this graph, and you can clearly see that if you drew a vertical line right through here, it would hit these 2 points. It also hits a third point, but that doesn't really mean too much to me. So long as it hits 2 points, I know it's a failure. So this right here is a failure of the vertical line test. So this set relation right here is not a function. This one right here, this absolute value function, is a function. Kind of ridiculous, I said function is a function. Okay, so as you can see that no matter which vertical line you pass through the graph, you're always only hitting the graph once, never hitting it twice with the same vertical line. Okay, so this is a function, and the first one was not a function. So when you do these practice questions, you're going to be using that vertical line test in class. I'll give you, not only we have graphs with coordinates, but sometimes the graphs will be drawn for you, and then you'll have to determine whether it passes or fails the vertical line test. Now, the next thing they want to talk about, or they do talk about in the book, is called function notation. All right, suppose we were going to play a game. So here's the game. You get to guess one of those equations, and I do mean guess. And I'm going to ask you this question. Now, you're only allowed to pick one of them. And you have to pick ahead of time. So pick your equation right now. Doesn't matter which one you pick. Well, it does matter, but I shouldn't say that. I'm going to pick one of those equations. And if you can answer this question, what's y if x equals 2? Now, you're only allowed to pick one of the three equations and answer the question. So you can only answer it with one equation. You can't do it for all three of them. In our little game, anyway. I'm going to pick one of those equations, and I'm going to answer the question. Now, if you are right with your one guess, you can get an A+ for the entire semester. Don't have to take any tests, any quizzes. I know there are a few of you that would like to take this opportunity to try. However, if you lose, if you are wrong, you can get an F for the semester and you need to repeat next year. Doesn't exactly sound like a fair game, does it? Because you don't know which of these three equations I've chosen, and then you're going to take x and plug it in for, or 2, plug it in for x, and try to find y. Not exactly fair. Okay, so let me see if I can make this game a little bit more reasonable. Now, every one of these things, f of x, g of x, h of x, and that's how it's read, f of x. So if you're at parties, that's how you would say it. Okay, f of x, g of x, h of x. All of those things are fancy terminology for y. Every one of those represents y. Now, I know you're probably saying to yourself, don't get in the habit of thinking this is f times x. That's not true. It's not like 5x or something like that. It's a way of naming the function. This still says y equals 3x minus 7. Y equals negative 2x squared plus 1. Y equals the square root of the quantity x minus 5. All those things are still said right here. But by using this function notation, we have named the three equations so that it is easy to tell. So now the game says find f of 2. And if you can answer this question, you get an A, and if you don't, you get an F. No, we're not really playing the game. But we are taking good notes, and so we should be able to pick the equation that we should be using and plug 2 in. So f of 2 is equal to 3 times 2 minus 7, 6 minus 7, which equals negative 1. So if that were the game, then I would have the winning answer. But I would know which equation to use instead of just being in the dark trying to figure out, well, what in the world? Which equation am I supposed to be using? Example 6 in the book. It says the area of a square tile is a function of the length of the side of the square. Area of the length, or the area of the square tile is a function of the side length of the square. Right. We know that the area function for a square, if you want to call it side length s, the area is equal to s squared. Well, with function notation, what they do is they write it like this, so that they're saying the area function, and they tell me that this is the independent variable. Now what's the dependent variable? The dependent variable is a of s. A of s. Sorry. I'm just thinking about writing out s squared as the product of two s's. Anyway, so they will give me a side length. They'll say find a of 4. Well, that's pretty simple, right? A of 4 is equal to 4 squared, which is equal to 16. All right, that's all there is to it. All right, so we'll have some questions to do in class tomorrow. When you get here, be ready, have your notes out when you get into class so you are ready to go. Don't waste any time, please. You've got some work to do tomorrow.